So this is a hydraulic ram pump based on the model from Clemson University. It's a fairly simple construction with a few valves and some PVC. Basically, upstream, I've got 30 feet of pipe with a little basin of water that I collect. The water comes down through that pipe. It's about a 4 to 5 foot vertical drop overall. Comes down through that pipe, goes through a simple on-off valve here just to be able to control whether I want it flowing or not. Then it goes through this swing check valve. That's the key. The two key parts of two key valves are the swing check valve and then a what do you call it? A valve that prevents backflow. So a backflow prevention valve. I've also got a union on here that I have found very helpful. In case any debris ever got through there, I can open that up and clean out that valve without any problem. But essentially the water comes down through, it wants to exit, so it slams that door shut. When it slams the door shut, it forces water through the check valve here, through that second brass check valve. Then as that pressure releases, the check valve closes, the door has dropped, and then it swings shut again. So it's just every second it's just pulsing, and with every slam it's pushing water through the check valve. So just a little bit at a time. It's not a whole lot, but I had this running overnight and filled a 275 gallon tank. This PVC tube up here is simply a pressure chamber. So as the water flows through, it wants to go up the hose, it wants to go up the chamber, whatever the path of least resistance. So as it starts working its way up the hose, and I've got 300 feet of garden hose going up to a tank, probably about a 30-foot vertical climb, 20 to 30 feet, I'm not sure exactly. But as it goes up the hose, it wants to push water up here as well, and that creates an air chamber of pressure. And what ends up happening is the air is pushing down on the water, which forces the water to go out the hose. So it takes about, I don't know, 2-3 minutes just to regulate the pressure when I first start this pump, and I have to manually open and close that little swing check valve. I just have to keep pushing it down because it wants to close itself. But once that pressure builds up, and I have a pressure gauge which is now broken, but I used to be able to measure the pressure. Once that pressure builds up in this tube above, that's essentially putting the downward pressure that pushes the water up the garden hose, up the hill, and into my storage tank that I can irrigate from. So fairly simple design. Just a few valves, on-off valve, swing check valve, a union for maintenance, and then another check valve here. And that's it. This thing's been running for, it'll run for weeks at a time. The only thing that slows it down or makes it stop is if there's a big storm and some debris gets caught in here. And I'll walk up here real quick and just show you what I've got going on. Now there's so much pressure and pulsating that I put these heavy rocks on here just to keep this pipe steady. And you can see it's just standard 10-foot sections. This I believe is 1.5 PVC, but you can size it to your needs based on how much flow you have and how much vertical drop you have. But you can see I just put simple little connections on here. And I've had these pipes in place now for probably 7 years. Never had a problem. I had the swing check valve break one time, had to replace it, but you can see here, there's a little vertical drop. So up in here, there is just a little basin of water where I'm collecting. I built this little dam basically, and then this pipe goes through the wall of that dam, and there's an inlet. You can't see it, but it's down in there in the rocks. Then I've got a metal screen over it just to keep out any big debris, but occasionally a crawfish or a stick will get through there and it'll jam up the valve down below, and I just have to clean it out. But that's pretty infrequent, usually after a big storm. And that's it. It just keeps on pumping. You can see it working down there, and it makes light work with no need for gas, electric, anything. Just the power of this water. The idea is about 90% of the flow is returned to the stream. That's the powering water, and 10% goes uphill. So it's not a fast pump, The water you're seeing coming out of that check valve right now is about 90% of the flow, so about 10% of that amount is what I'm getting up to my tank. But like I said, for a slow, if you're filling storage tanks, my tank this morning, I turned this on last night, and this morning, 10, 12 hours later, 275 gallon tank was full and overflowing. So I don't know how long it took, but it works great for garden irrigation. All right, that's it. I'll put a link to the plans with the video.